So I want to create a program that converts basically somebody's height in inches and feet in inches to meters. Now I want to do this through several classes. This is a very simple task, but I want to do this through several classes. And the way I'm going to do it, I want. Let's assume this is a big project and there are several classes for each of the several things that I want to accomplish. I don't want to have one directory with many classes there that it's just so hard to find the one class that I want to work on. It's just very hard to organize anything. So what I'm going to do is I'm going to split my classes into directories that will host just a related amount of classes. So for example, I'll have a directory called unitconv over here for unit converter, where my little unit converter will sit. Okay, my unit converter here, it's a public class, and it has static method feet to meters. You enter the feet as a double, and it gives you a double with meters. Inches to meters, you enter a double I for the inches, and it'll return a double with the meters. Meters to feet and meters to inches in the same way. You can look at these methods. They are static, so I can just say unit converter dot feet to meters and then give it a number. I don't need to create an instance. That's what static is, and you can check the video on static variables to understand that. But the main point here is there's a class and that I have methods that I want to perform in this class. The other interesting thing is because this is, I have a root directory here, whatever this root folder is. Now because the unit converter is under unitconv directory, I have to add this line at the top, package unitconv. That will tell a lot of things to the Java compiler, but will also tell me, the coder, that this should be in a folder called unitconv, which actually that's where it is. Okay, that's the unit converter. Now I have an enhanced unit converter here under the enhanced UC folder. It's under the enhanced unit convert. That's why I have to create it with the package enhanced unitconv. Now this class will use the unit converter that I created before. So assuming that this is going to be the root folder for the project, I want to use that unit converter. I want to use the unitconv unit converter class. Okay? So I'll go to my enhanced unit converter and I will import unitconv, so that folder's that package. In that package, I'm going to import this class. If I had other classes under the directory unitconv, I could import them like this here, right? This is what import means. You're bringing something from a package. The package unitconv bring the class unit converter. So whenever in my program I use the class unit converter, so for example here, unit converter, it's referring to the unit converter that is in the package unitconv. Okay, this is how I cross-reference classes that are in other directories. Now my enhanced unit converter, the idea is that you give it a string with your height, for example, like 5 feet 2 inches, and it will return, the unit converter will return whatever that has 1.52 meters, I think. And it does it by doing two things. First, extracting the feet component of a string input. So given 5 apostrophe 2 apostrophe apostrophe, it will return the number 5. It does this by splitting the string. You should take a look at what split does if you don't know, but splitting the string on the feet and then parsing as a double the first number of that split. So splitting the string in apostrophe basically will give you an array with 1 and 2 elements, perhaps 3 elements if there's a null. The first element of which is 5. The second element of which is 2. So, given an input for feet, I will do some magic and I will output just the first number of the feet. In the same vein, return inches actually gets the same string input. it does the same operations, but then it returns the second bit of it, which is the number 2. Okay? Now, given a string like 5 feet 2 inches, what it'll do is you give it this input, double feet is going to be the feet, double inch is going to be the inches portion of it, and double m is going to be unit converter feet to meters, ft, and then add to that the unit converter dot inches to meter of the inches, and that is your height in meters. That's the main method. So the enhanced unit converter returns your height in meters given a string. Okay? But for that it uses the unit converter, which sits in the package unitconv. Now enhanced unit converter sits in the package enhanced UC. Now in the package enhanced UC I also have a sub package called test, or subfolder, and the classes under this, like test enhanced unit converter, this is just a test. Okay, this class, the package that I need to put there is enhanced UC, because that's the first directory which this is under. Enhanced unit C dot test. That means that this should sit in a directory test under enhanced UC, under whatever the root of the whole project is. And I want to include the enhanced unit converter that is in the directory enhanced UC, and I import, and here it is, I'm using it and it's included. You can take a look at this class. All it does is just test this. Okay, and we could we could do a bit of that would be just to test it. And then in the root directory I have a convert height, which basically brings the enhanced unit converter. It imports that. It also imports the JUp Champagne so you can enter your height. And we can test this, right? So we can compile this. What it'll do is it'll use the JUp Champagne to enter a height as a string, and then with the enhanced unit converter it'll create a new enhanced unit converter, and then it will say you are, and then return your height in meters. Okay, that's all it does. So let's run it. And as it runs, the JUp Champagne is a graphical way of input as opposed to a scanner. So enter height, 6, 7. Okay, and it told me I am 2 meters high, right? So I'm 2 meters tall, I would say. So this is basically what this program does. Everything is organized in folders and packages.